Hello. Hello to all Honors College Algebra students. We're going to be moving on today. Last class, we learned how to simplify radicals. Now we're going to solve equations and we'll have to simplify the answers. So to solve this first problem, we would subtract 5 from both sides of the equation. Oops, grab a pen. So you'll get 3n squared is equal to 114. Then we're going to divide both sides by 3. 3's canceled out here. You'll get n squared is equal to 38. Now we're going to take the square root of both sides in order to solve this equation. And when you take the square root of both sides, you always must take the plus or minus. And the reason for that is because if you square a positive number, you'll get the same number. And if you square a negative number, you'll get the same number. So that means that's why you have to do plus or minus. Okay, so what we get here is n, since the square root and the square cancel each other out, equals plus or minus the square root of 38. So this is an exact answer. Because we can't simplify, get rid of that. We can't simplify 38 because if you did a factor tree for 38, you'd get 2 and what is that, 15, 19, right? So both 2 and 19 are prime numbers because they only have factors of 1 and themselves. So that's how you know you can't break down the square root of 38 anymore. So that's your exact answer. If you wanted an approximation of this, you put the square root of 38 in your calculator, you'd get approximately 6.16. And since we're approximating, let's change this from an equal sign to an approximation sign. Approximately. All right, let's do the same thing to the other problem. We're going to add 3 to both sides of the equation to get 9n squared is equal to 171. Then we're going to divide both sides by 9 to get n squared. Let me make that a little more legible. N squared is equal to 19. From here, we're going to take the square root of both sides. Remember, you have to take the plus or minus. So you have n is equal to plus or minus the square root of 19. And as I mentioned, 19 is a prime number, so we know we can't break it down any further. All right, so to get an approximation of that, we would say n is about equal to plus or minus 4.36. Okay, so we've done problems like that in the past. Let's look at some new stuff. All right, so solving equations with whole number exponents. So a whole number exponent is like that's the exponent and it's a whole number, it's not a decimal. All right, so first thing you're going to do is isolate the variable on one side of the equation. So the variable is x cubed, right? So we got to get rid of 40. So you're left with x cubed is equal to 15. So now what we're going to do, and since we can't take the square root, we're going to take the cube root because that's what will make the 3 go away. Or you know what, I'm going to do this in a different step. So we're going to take the cube root of both sides of the equation. So x cubed and the cube root will cancel out, and you'll just be left with x. And this is equal to should be plus, no, that should not be plus or minus. So when you take the cube root of a positive number, you're just going to get that number. There's no plus or minus for any for any odd root. So x is equal to the cube root of 15, which is approximately equal to 2.466. Well, I think what we should just do, well, I'm doing 3, 4, 6, so 3 decimal places. All right, let's try something that's raised to the 5th power this time. So the first step is the same. You're going to isolate the variable on one side. So first we have to get rid of 73. So we're left with 2x to the 5th is equal to negative 20. So now we're going to get rid of the 2 by dividing both sides by 2. So you'll get x to the 5th is equal to negative 10. So now we're going to take the 5th root of both sides. I'll show that as a separate step. All right, so this will simplify to x, and this is going to simplify, since we can't simplify 10. What you know is if you're taking an odd root of a negative number, you're going to get a negative. So we know that this is going to be negative 5th root of 10. Oops. Or if you wanted an approximation for that, you could say x is approximately equal to negative 1.584. And that would be solving for the variable. All right, this time we have something in parentheses raised to the 5th power. So notice that in step 1, it says isolate the variable or parentheses. So there's nothing else there but the parentheses. So what we're going to do is we're going to jump right to step 2, where we're going to take the root of both sides using the exponent as the index, right? So we're going to take the 5th root of both sides. We're just taking that. So 5th root and 5th root of both sides of the equation. So the 5th root and the exponent of 5 cancel each other out. So you're just left with x plus 10 is equal to the 5th root of 70. So 70, you can't simplify the fifth root of 70 anymore. So what you're going to do is you're going to go back and solve this equation. Oops, we're going to subtract 10, not 5. I think I'm still on the fifth root. All right, subtract 10 from both sides. And how you would write your final answer then is x is equal to, remember it's an odd root, so we don't have to worry about taking the plus or minus. And if you're taking the odd root of a positive number, of course, it's going to be positive. So we just have the fifth root of 70 minus 10. But generally, how this is written is the number would come first. For some reason, some mathematicians said, we're more interested in that number than we are the fifth root of 70. If you want an approximation for that, x would be approximately equal to negative 7.66. And it's negative because 10 is more negative than the fifth root of 70. Remember, the fifth root of 70 is just some decimal approximated number. All right, let's try a few more. So even exponents, this is a reminder that if all of these are even, so they're going to get plus or minus solutions. If they're odd, you don't have to worry about the plus or minus. So the first step is to isolate the variable x to the sixth here. So we're going to subtract 36. So we get x to the sixth is equal to 64. So from here, we're going to take the sixth root of both sides. So we just get x here. And notice we have to do plus or minus. So we get x is equal to plus or minus the sixth root of 64. If you put that in your calculator, you'd actually get a whole number, which would be 2. All right, let's try this one. Let's see. The first step to getting x to the fourth by itself is to divide by 7. So 56 divided by 7 is 8. So we get x to the fourth is equal to 8. So from here, we're going to take the fourth root of both sides. And we also have to add in plus or minus. So x is going to be equal to plus or minus the fourth root of 8. That's an exact answer. Now let's go to Desmos to show you how you would put the fourth root of 8 in a calculator. Should have already had it up, but I did not. And we want the scientific calculator. So let's see, the fourth root. So we're going to say this, we're going to put a 4, fourth root of, we got to click under that, 8, and you get that approximation, 1.68. So our approximation is x is approximately equal to plus or minus 1.68. All right, here, remember that first step is to isolate either the variable or the parentheses. So there's nothing else here except for x minus 5. So we're just going to take the fourth root of both sides of the equation right off the bat. So we're just left with x minus 5 on the left. We want to do plus or minus, since it's an even root. And we get the fourth root of 256. Let's try that on Desmos again. We want the fourth root of 256. So we're going to do this. Fourth root of 256 is, oh, it's a whole number. Look at that. Okay. So, okay. So now what we have is we have not solved the equation because we haven't isolated the x yet. So we're going to go back and add 5 to both sides. So we have two scenarios. We have x is equal to positive 256 plus 5, or x is equal to negative 256 plus 5. So 256 plus 5, no, not 256, because the fourth root, oh, let me go back, sorry. This should have been 4. Remember, we calculated that. Thought those high numbers didn't look right. All right. So the fourth root of 256 we found out was 4. Oops. Okay. So now, if we add 5 to both sides, we have x is equal to positive 4 plus 5, or x is equal to negative 4 plus 5. So our two answers will be 9 or positive 1. All right. Now, this is just reminding you that even exponents get plus or minus solutions, right? So the only even exponent is here. So the other two, you don't have to worry about plus or minus. All right, so the first one, we're going to get rid of the 6 by subtracting it. So we have negative x cubed is equal to 8. Then we're going to get rid of this negative 1 by dividing both sides by negative 1. So we have x cubed is equal to 7. Why am I saying 7? No, positive 8 divided by negative 1 is negative 8. Okay, now an even exponent, well, let's just do this problem. Okay, so from here I'm going to take the cube root of both sides. And you are allowed to take the cube root of a negative number. If you take an even root of a negative number, that's where you have to remember to put I in your answer. All right, so we have x is equal to, well, let's go back to Desmos. Cube root of 8, let's say negative 8 even. Let's say negative 8, oops. See, it shows you in Desmos, you're still in the index area. You got to actually click down there to get it. Let's say negative 8. And we get an answer, which is negative 2. So remember, the cube root of negative 8 equals negative 2 because negative 2 cubed is equal to negative 8. All right, so the next problem, we have to worry about plus or minus because the exponent is an even exponent. There's nothing else around except for the parentheses. So the first thing that we're going to do is take the 6th root of both sides of the equation. So we're left with 2x plus 5 is equal to the 6th root of 120. Maybe we'll go to Desmos for a quick sec to see if there is a 6th root of 120. I don't believe so, but how would you know? Let's see. 6th root. Here, 6th root of, just making sure it's not a whole number. And it's not, right? So double check to make sure that it's not, but it is not a whole number. So what you're going to do is just carry it forward. So now we have to isolate x. So what we're going to do is subtract 5. Negative 5 plus or minus, right? Let's stick that plus or minus in there. The 6th root of 120. All right, now we still haven't isolated x yet. So what we're going to do is we're going to divide both sides by 2. So now we have x by itself. And the most that we can do, if we're running an exact answer, is that. Now, if you wanted an approximation for that, go back to Desmos. You would say negative 5 halves, so negative 5 divided by 2. And then to get out of this, use these cursors, plus or minus, here we'd say, plus, can't put the minus in yet, we're just going to edit it, plus the 6th root of 120 probably we need a parenthesis here, here, and then say divided by 2. So negative 3.61 is one estimate. Now, if we edit this, we don't have to put it in twice and say we want the other answer. That would be the other answer, negative 1.39. So x is approximately equal to negative 3.61 or negative 1.39. Okay, and number 10, we can't just take the 5th root of that because we got to get rid of that negative 1 that's implied here. So we're going to divide both sides of the equation by negative 1. So you have 4x plus 1 to the 5th power equals negative 25. Now we're going to take the 5th root of both sides. So you're left with 4x plus 1 is equal to, now remember it's a 5th root. That's an even number, it's an odd number, so you do not need the plus or minus. So we've got the 5th root of negative 25. All right, so the 5th root of negative 25 is a decimal, so we're not going to worry about that right now. All right, so what we're going to do is solve for x by subtracting 1. Now, because it's a negative number, we can take the fifth root, an odd root of a negative number. That's totally legal. And then from here, we're going to divide both sides by 4. So you have x is equal to negative 1/4 plus, and then the fifth root of a negative number is always going to be a negative. So it would be plus negative fifth root of 25. And then to get a decimal approximation, x is approximately equal to negative 1/4. Nope, sorry, that's the exact answer. So one answer would look like, oh, there's only one answer here. So it would be negative 0.68. Let's practice one more time putting that in the calculator. Okay, we have negative 1/4. So I'm going to say negative 1 divided by 4. And then to get out of that denominators part, I'm going to just use these scroll keys over here. We're going to say plus, and I think I'll put this in parentheses since it's a fraction too, fifth root of negative 25 divided by 4. I thought I might have been off. It's negative 1/4 plus the fifth root of negative 25 over 4. Yeah. So let's go back and change that to 0.226. Let's see if this makes a difference. I think it might, because I have parentheses around the whole thing. Let's see. So it's negative. This is, yeah, it would be negative 0.726. All right, so let's go back to our, write the correct approximation. Good thing we used Desmos, right? Negative 0.726. Okay, I think that's all the examples I have for you today. I will post this on Schoology for you, and there is an assignment. Remember, you can always email me and we can meet privately if you have any trouble with any of this. And many of you have been emailing me suggesting that there might be an error in some of the exit tickets, and you have been right. So please don't, I can make mistakes. So just email me if you suspect there's a mistake or something, and I'll fix it in your grade book and all of that. All right. All right, you have a lovely day, and I will see you in the next video on Friday.